What you see on the screen is a composite raster image from Sentinel-2 from 20 September. These will be used to illustrate the calculation of an index in QGIS. An index is based on specific bands of a raster image. You are manipulating only very narrow reflectance values or bands within an image to extract certain features. This video will illustrate the NDVI, the Normalised Difference Vegetation Index. The NDVI is based on the principle that healthy vegetation absorbs in the visible light and reflects in the near infrared. This is based on the capabilities or characteristics of chlorophyll. Sick plants absorb more of the near infrared than healthy plants. The healthy plants specifically reflect very strongly in the green of the visible portion of the electromagnetic spectrum, and they reflect very strongly in the near infrared. This is what the NDVI calculation is thus based on. The NDVI is an index that ranges from -1 to +1, and the purpose is to identify healthy or unhealthy vegetation, although it also does include the absence of vegetation, because that is more or less equivalent to unhealthy vegetation. If you have negative values, specifically the closer you get to -1, you're looking at things such as cloud, water, snow. So this is hydrology related. If it's close to 0, you're looking at rocks and bare soil. So it doesn't mean that it's unhealthy vegetation. It just can also mean there's just no vegetation at all. Then if you're going to values around 0.2, you're looking at shrubs. If it's going to around 0.6, it's deciduous trees, and the really strong green leaves, tropical forest and the like, you're getting to values of about 0.8 to up to 1. In order to do this calculation, you have to manipulate the red and the near infrared bands of an image. Specifically, the NDVI is calculated by subtracting the red band from the near infrared band and then dividing that by the sum of the near infrared and the red band. That means you have to have an image that actually has those bands stored separately, so it has to be a multispectral image, so more than one band stored within the image itself. If you go to the properties layer of your raster and you scroll to where you have the band information, you'll see that this particular image has 6 bands. Now, this is a composite image. I created this myself. Band 1 is the blue band. The band 2 is the green band. Band 3 is the red. Band 4, the near infrared. 5 and 6 are infrared 1 and 2. In order to calculate the NDVI, I go to the raster calculator from the raster menu. And from here, I then select only those bands that are important in the calculation. I know that band 4 is my near infrared, so I add that first, and then I must subtract my red band, so that's band 3, from that image. That is the first part of the NDVI calculation. And close this in brackets because it uses normal mathematical sequencing. Brackets are calculated first, then multiplication and division, then addition and subtraction. So I have to then put in the near infrared band again, that's band 4 in this case, and then I add the red band. And this is the calculation to determine the NDVI, the Normalised Difference Vegetation Index, using this raster calculator in QGIS. For this example, I'm going to do a temporary layer. I'm going to use the extent of my input layer, which will automatically put rows and columns. I'll also use the same coordinate reference system that is the coordinate reference system of my input layer, and I run the results. This creates an index of -1 to 1, which relates to the possible values for the NDVI. I can also symbolize this to allow me to better visualize what I'm seeing. For example, I can load a layer style. Now this has already been symbolized into logical subdivisions. So in the NDVI, a value of -1 is normally water or snow or anything hydrology related. 0, around 0 tends to be bare soil. It's not unhealthy vegetation, it is the absence of vegetation as well. And around 2, you normally have shrubs and meadows. Around 6, you tend to have deciduous trees. And then the very strong green, or values of 0.9 to 1, tend to be the very healthy, dark foliage that you would expect of a forest or tropical forest. So this just helps in visualizing the data. So when you have a look at the output now, areas are indicating as very strong green or stronger green. Now, these are the areas where if you would actually switch off the NDVI result, you could see this is actually a field. So this has irrigation. It's an irrigated field. And this shows as having healthy vegetation in the NDVI calculations. You can also see that the brown, you can see here and up there, the brown is not always reflective of bare soil. So this is actually an urban area. So the NDVI is not very good at picking up urban areas. There is a confusion when it does the calculation because it focuses specifically on the bands that relate to healthy vegetation. So you can't use it as an answer for everything, but it does help in extracting the healthier vegetation, which is shown as this stronger green color in the image.